Hi everyone, today we'll be working on question number 50 on LeetCode called 3sum. Idea is really straightforward. We want to get all unique triplets in an array which gives a sum of 0. So, let's talk about the brute force algorithm first. Is to do a triplet nested loop, go through every single possible value, make sure you have no duplicates, then check if the sum is equal to 0. So that's just O n cubed for iterating over the loop 3 times over. But we can do better. And the optimized solution using 2 pointers is O of n squared. So let's use paint to kind of figure out why that's the case. So let's use our example here. So for us to use 2 pointer, we should actually sort this first. And we know that sorting takes n log n time. So this gives us -4, -1, -1, 0, 1, 2. So for 2 pointer, we can always say that we can choose one value, which let's just say is -4 for now. And 2 pointer will start from the front, in front of that initial value as well as the back, and search for values that add up with -4 to 0. And through that, we know that 2 pointer is O of n. So together, because we're choosing one value every single time we iterate, and then 2 pointer the rest of the array, we can say this is O of n times O of n, which is O of n squared time. We know that O of n squared is always going to be asymptotically greater in runtime than the n log n. So in fact, the fact that we sort doesn't actually come into play when we're calculating the total runtime of our solution. So with that, let's get started in writing this. Let's sort our numbers first. Okay, so now sort our iteration. I'm going to say nums.length -2 because this is the last index that can hold 3 values. So we would end up only iterating up to here. Let's actually call result to hold our results. And let's also skip any duplicates because we definitely don't want to be iterating over -1 and another -1. So we can say if I is not 0 and nums I equals nums I minus 1. Continue. So that's how we skip the duplicates. Now let's call our 2 pointers. So let's say let j equals I plus 1, and let k be the end of the array, so nums.length minus 1. And we can say while j is equal to k, find the sum. The sum would just be nums I plus nums j plus nums k. And so if the sum is equal to 0, we want to push these 3 values into our result. So we can say result push. And we can also skip all of our duplicate values in our 2 pointer iterations. So we can say while nums j equals the value in front of it, skip it, and while nums k equals nums k minus 1, skip it. So the reason why we do nums k minus 1, we compare with the back values because k is moving towards the left while j is moving towards the right. And at the end, we can just move our pointers. Cool. So let's say if the sum isn't 0, what if the sum is less than 0? This is straightforward then. We just want to move our pointer, our j pointer up, because the j pointer will get us bigger values by moving right. Otherwise, if the sum is greater than 0, we want smaller values, so we move our k pointer to the left. And that's about it. So at the end, we return the result. Let's see if this works. Cool, works just fine. That works just fine. So as I discussed, sorting does take all of and log in time, but it doesn't actually count towards the runtime of this question because we have a higher bound here of O n squared by using 2-pointer. So that just about sums up my explanation of this question. I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.